I'd like to discuss the display format of the design control points within the ZWave work screen. There are basically 4 control points for the design of the back surface of the contact lens. If you hover with the mouse over each control point, you'll get a readout that shows what the control point designates. This is the back surface optic zone, and it has a chord diameter of 7 millimeters. The lift is about 3.4 microns away from the cornea. The second control point is the intermediate position, and it's at a chord diameter of 8 millimeters, and it's closer to the cornea. We have some bearing in this meridian, as you can see here. The third control point is the bevel indicator. You can position it at different locations. This current one is at a chord of 9.3, and then we have our edge lift, which is the last control point to the right. Anytime we want to measure the tear layer thickness at any point in this meridian, we simply hold the mouse over the tear layer graph, hold the left mouse button down, and we'll get a readout in the upper left corner indicating how many microns of clearance is between the surface of the contact lens and the cornea underneath. We are shown at what chord diameter we're at this location down into the left of the tear layer graph. As you can see, when I'm at the optic zone, I'm close to about a chord diameter of 7 millimeters. And when I hover over that, we see we do have an optic zone width of 7 millimeters. Similarly, when you're looking at the other display formats, we can use the cursor to show us what the curvature is at different positions. For instance, if I'm at a chord of 2 millimeters, we have a back surface radius curvature of about 7.7 millimeters. We can inspect the front surface of the contact lens in the same way. And here we have 2 more control points. Whenever we're using a bifocal design, we can designate the position of the ad. The bifocal is generally a distance center design with the ad in the periphery. And the size of that distance area is determined by the position of this control point, the distant pupil size. The default is 3.6 millimeters. That has been what's worked best. This next control point is the anterior optic zone. As you can see, we can make it larger if we want to, and we'll get a junction on the front surface of the lens. If we keep it to a smaller size, it will prevent us from getting too close to the pupil because we need a certain area to create our ad with. If I push this too far to the left, it will prevent it from going any further. These control points can all be just dragged and dropped with the mouse. You just place the cursor on the control point, hold the left mouse button down, and as you move it, you'll see an indication down and to the left of how far you've moved it. I'll leave it where it was so there won't be any recalculation done. We can do the same thing with the tear layer control points. For instance, if I want to raise the edge lift on this lens all the way around, I can simply get this control point for the bevel position and hold the left mouse button down and pull it to the right. Now, if I go far enough to the right, it will be prevented by maximum. But you can see I was able to lift the edge all the way around the lens with that control point. This indicator in the upper right-hand corner of the floor scene simulation shows what percentage of the lens I'm affecting by any of my design modifications. For instance, if I'm at the superior 12 o'clock semi-meridian and I put this on 25%, I can raise the edge lift further, and you'll see I've only raised it at the top and at the bottom of this lens because it's a geometrically symmetrical lens. Similarly, if we have this set at 50%, our lens design will be changed halfway around the lens. And you can control sectors of the lens design by setting this control to 100%, which affects all the way around, 50%, which affects half of the design, or 25%, which just affects one quadrant, as you make these control point modifications. The lens profile display area is in the lower left corner of the ZWave work screen, and it shows the lens power and base curve in the meridian that you're pointing at currently. It also shows the center thickness and edge thickness of the lens. If, for instance, on this geometrically symmetrical lens we point at another meridian, we will get a different lens power and a different base curve because this lens has a varying base curve as you go around the lens. Now, keep in mind, in this mode, the lens will be identical on both sides of the lens, but nevertheless, you can see what the curvature and the power is in different meridians. The center thickness is generally minimized, but it's always a good idea as the last step to always choose your minimum thickness and let the program calculate for how thin the lens can actually be. Edge thickness can also be varied. I personally like a very thin edge, but there may be occasions where you want to use a thick edge. Whenever you enter an over-refraction that has any cylindrical component to it, there will be some prism ballast placed on the lens, and that will affect the center thickness because, as you can see, this lens is thicker as we look at the lower aspect of this lens than it is on the upper aspect, and that's what increases the center thickness. So you'll have a greater center thickness for lenses that have toricity on the front surface. With that in mind, I generally like to really reserve this for cases where I absolutely need that cylindrical over-refraction because it keeps my lens thickness possible to keep it down to a minimum, and we can get a little thinner profile for the lens. But this lower left corner is where you see how the lens thickness is distributed on the surface of the contact lens. There is another occasion where the lens will be made thicker because of prism ballast, and that is if on our front surface design we make the pupil less than 2.4. When we make the pupil that small, the design changes to more of a segmented type of a design. And with our ad distributed only in the lower portion of the lens, this lens must orient properly, so there's prism included in the lens design. As you can see when we look at the bottom half the lens, it's thicker than it is at the top once again. This lens doesn't have any astigmatism correction on the front surface, but it does have this bifocal design with a very small pupil size, and that's what creates the need for the prism ballast and the increase in thickness. So keep in mind, whenever you use a very small pupil size, you'll have greater thickness, or whenever you have a astigmatic over-refraction, you'll have a greater thickness to your contact lens design.